Hello guys, just want to present my little bit of research on Evaldraw gaskets done inside the Evaldraw environment as this little script. An Apollonian gasket is a fractal packing of circles. All of them are touching each other through other circles. It all begins with just 3 circles, which can be any 3 circles inside this gasket, and they always end up with the entire net that has infinite number of circles, but there's only one circle that has negative curvature. I mean that it encompasses the rest of the circles, and the rest of them have positive curvature, and these curvatures are determined using the so-called Descartes theorem, this relation of radii of these circles. So you can always construct 2 circles from 3 mutually tangent circles, or it may be a circle in the line, or like in this limiting case. But this script has always the outer circle fixed radius, and the rest of the circles are constructed from just 3 circles until there is some minimum size reached. And I like this fractal because I think it's a perfect depiction of a ecosystem that can host everything, every smaller, increasingly smaller niche products. There's always some mass market. It can be thought like you have increasingly smaller filling the increasingly smaller space, and there's always some space to fill, so you have infinite possibilities. So this is the meaning I think I like to think of the gasket like this, and I came up with a triangle shaped perimeter space that contains every possible gasket in a convenient way, so there are just 3 extremes. You can see that these extreme, you have this gasket that can be found here. It has integer curvatures, and here you can set up the curvatures so they are integer as well. And there's also sound feature, so you can ring every little circle, and here the sound produces is basically the frequencies proportional to its curvature, inverse proportional to its size. And you can ring them, all of them at once. You can change the shape and hear how the sound changes as well. So there's another extreme that is a perfectly symmetrical gasket that has all these starting circles the same sized. This one has a symmetry. It's called it's not integral, of course. It has D3 symmetry, and there's only one gasket that has this kind of symmetry, and the rest of them have either this kind of symmetry or this kind of symmetry, line on this line, and also there's the degenerate case that has only this large circle, and the rest of them are infinitely small. It can be viewed like this limiting case. So there are two parallel lines that are exactly like this. The gasket, maybe it resembles the gasket inside your car engine, so it's named like this. And there are just two parameters to create any gasket. That will be, well, there's also a nesting function, so you can create nested gaskets inside these circles, any of them. Just be cautious because you are going to run, so your circle count will blow up exponentially very quickly, so you likely want to restrict your maximum curvature to smaller values, and this restriction you can make a gasket like this, so it will host more and more circles inside the other circle, looking like this. There's also very experimental mode. In fact, there are 3 modes inside the script. There's fast mode that just creates the gasket, and the sorted mode puts all the circles in sorted order, so you can choose the display of indices. And in this display mode, these circles, when in sorted mode, they will go in sorted by their size, starting with the first circle being this one, and the rest of them are sorted in descending order. And if you use the fast mode, there's no sorting at all, so they are placed like they're created by the algorithm, and the algorithm uses the the fact that the gasket is homeomorphic to Sierpinski triangles, which can be seen if you know what Sierpinski triangle is. It's a triangle that resembles this shape, but made of points instead of circles, or increasing the smaller triangles. And this gasket is made of circles, but it carries some resemblance to the Sierpinski triangle. It's also a fractal set of points. I like to think of it like well, so there's sorted mode, there's also fractal mode, very experimental, can be tweaked inside the script. And basically it generates points inside the gasket that are infinitely nested gaskets, so they are a gasket. There's a gasket inside each circle, so you can see that they are form a Apollonian sponge. A sponge, I think. Well, so you can see I put in every stupid idea I have into this script. There's sounds, there's fractal tracer, there's this triangle of parameters that are U, V, W, they always sum up to 1, and they're associated with chroma. No, well, they are chromaticity coordinates. They're also use a triangle shaped space. If you used a RGB color picker, it might be resembling that. And there's integer mode that can be used if you're looking for integral Apollonian packings like this one or this one. They're interesting from musical perspective because they are more likely to contain consonant intervals that have just intonation. The just intonation has some rational intervals, rational numbers of multiplies of frequencies, and these circles have rational curvatures. So there's another display mode that contains, well, it displays cents, and a cent is a musical interval scale. 100 cents is a chromatic semitone, so you can see that there's a 700 is a perfect fifth, and the curvatures are related like 3 to 2. So it's just interval of the perfect fifth, and there's also an octave here, and you might spot some other intervals, but this one is not very musical, and might the rest of the packings are also quite weird sounding, so there's not much of a consonance here unless you find some interesting relation by ear. They sound pretty much like that. So the entire triangle is filled with these weird sounding gaskets that I think contain a little nice sounding intervals, unless you go into the integral mode. And this integer mode allows you to select the base number, and you can also pick the reference circle. You'll likely want to use this largest circle as the reference and use the rest of them. So there's also a feature that allows you to quickly spot the integer gaskets. Here it says 3588, so you find this one, and -3 is the outer circle curvature. So there's only one circle that has negative curvature. And this one is the gasket that is present on the Nip Labs logo. So I think it's most interesting from the musical perspective, because you see here you have the 8 to 5, which is, you can find is in just intonation. Which is a list of intervals that are So it's pretty interesting to find some intervals in this geometric construction. So there's, if you go to the centered mode, you can easily spot here's the two octaves apart, and there's also some other circles that are also 2 octaves apart. This one is perfect fifth apart. Here is the minor 6th, and here's the major 6th. Interesting intervals you can find if you look deeper, but it will take some time to find and locate. So something that here's also a perfect fifth, because these curvatures are, well, this fraction reduces to 3 to 2 as well. So there is also other integer packings that can be constructed for other starting curvatures, for example. So this one has 3, 2, 3. This here is C, 2, 3, 6, 7. This means that the 7 is here. And there might be other more intricate constructions. There are infinitely many integer gaskets can be constructed, but the larger the curvature number, the less likely to sound good, I think. So you'll end up the same weird sounding gaskets. Well, and this gasket sounds like this. So there's another, when in sorted mode, there's a ratios displayed between the consequent circles. For example, if you start with this one, with this extreme, the first 2 circles are equal, so they have ratio 1, and the next circle is 2/3 the size, and the next circle is the same size, and the next circle is half the size of this one, so there's 1/2 halfway, and the rest of the ratios can be visualized using this weird waveform. Can't tell how it sounds, might sound pretty noisy, and my first guess is maybe a Fourier transform could be applied to that, could produce some interesting frequency patterns, I think, or not. So here's what the script can do. And in fast mode you don't have this ratio displayed because the circles have to be sorted in descending order for these ratios to be displayed. So you can see indices display curvatures in relation to the reference circle, or alternatively you can display the same ratio expressed in cents to estimate the musical interval it might produce. And the max curvature is limited, so there's about 8,000 circles in total. It's rather detailed construction, I tell you, because when you export these numbers as they come as separate values, you can use these data in other applications. Just press X to turn the export mode, and then the F6 will save the file in CSV format. So here it is. You might want to just tweak some variables if you know what you're doing, but the script is pretty experimental. Many features are, well, they could be further elaborated, and despite being well structured, might always be friendly to, well, easily maintainable thing, because it's just a Evaldraw script. It contains everything that needs to display, construct these gaskets, and it's not much you can do about it, because this language resembling a C language, but it's pretty different. You don't need to declare your variables. You can place your functions in any order you like, and you don't need to prototype. You don't need to use variable types. You don't need to use, well, your local variables. You just type them and use them. It's convenient for prototyping tasks, but the language is rather slow, and but I like using this environment because I'm used to it, and I've been using it for 20 years now, and you can do, I like the instant feedback you can have, because when you change your code, you can see and there are some built-in modes for graphing, plotting, and musical instruments and voxel levels. So there are some other scripts in the making I'd like to show you, but that's it for now. Thank you for stopping by. See ya.